another type of pattern. So you've probably looked at the linear, or also called arithmetic, the geometric at this stage, and now we're going to look at quadratic. So you should be familiar enough with the word quadratic because you've been dealing with quadratics for years now. So, you know, the typical quadratic that you've been looking at is something x squared, something x, and another something. So that's what a typical x, or a typical quadratic looks like. So we normally have something x squared, so maybe ax squared plus bx plus c maybe. So that's just the word quadratic. If we look at a quadratic pattern, now this can link to your functions if you do it the other way around. So if you had the function x squared plus 2, you can, anywhere you have an x, throw in whatever you want. So if we threw in a 1, you'd get out a 3. If you threw in a 2, you'd get out 6. If you threw in a 3, you'd get out 11. So the pattern would be 3, 6, 11. So what I might do in order to check how I know that's a quadratic, or how, you know, how to even just notice anything about a quadratic pattern, is if I start looking for a common difference, like I would with a linear. Now, because it's not linear, you shouldn't get a common difference here. Okay, but what you might notice is that if you went a second time, that you will get a common difference. So if you were given this, you can create this. And now we've just started to look at what are the patterns that I need to look for in order to recognize a quadratic pattern. So you probably won't get this. You know, you won't get the general term for a quadratic. So you need to be able to, as always, recognize the pattern. So now we're trying to recognize, is this linear? Is it geometric? Or now is it quadratic? And the way we recognize a quadratic pattern is that, okay, the first difference won't be common, but you will have a common second difference. So if we have a look at another one, 1, 3, 6, 10, and so on. You're going to check if it's linear. No, it's not. But if I go for a second difference, we have a common second difference. So this is quadratic. So that's how I recognize it. What if I want the 100th term of any pattern? The 100th term of any pattern requires that you get the general term, as always. If you want the general term of a linear, you go to your log tables, you get the formula in your log tables, and you fill it in. If you want the general term of a geometric, you go to your log tables, you get your formula, you fill it in. If you want the general term of a quadratic, then you go to your log tables and there's nothing there. So you're going to have to try and work out how will you get the general term. But you don't need a formula in the log tables because you are used to dealing with quadratics for many years now. So as we said, quadratic usually looks like something x squared plus something x plus something. So if we want Tn, okay, so we're going to talk about instead of x, we're going to be using the variable n. It's going to be a n squared, so something n squared plus something n plus something. So at most, or at the longest, that's what your general term of any quadratic pattern will look like. Some of them might be shorter. It could be like 2n squared plus 3n, or just maybe 5n squared. They can be shorter than this, but at most, that's what it will look like. So if I get an example of, let's look at this one. 12, 16, 23, 33, and 46. Firstly, you need to check if it's quadratic. And so that's 4, 7, 10, 7, 10, 13. It is not linear, but if you look at your second difference, we have a common second difference of 3. So I definitely know it's quadratic. The general formula for a quadratic looks like this. So I'm going to have to use this and the information that I have from my pattern and try and figure out the general term. So what do I know? I know that T1 is equal to 12. So anywhere I have an n, I can put in a 1 and I can let it equal to 12. So that's a times 1 squared plus b times 1 plus c is equal to 12. Clean that up. That's a plus b plus c is equal to 12. That's that done. What else do I know? I know that T2 is equal to 16. So anywhere I have an n, I can put in a 2 and let it all equal to 16. I guess this is actually really helpful for your functions as well. It's, you know, this is basic substitution in, so it's helpful for your algebra and your functions. So anywhere I have an n, I can replace it with 2. So I end up with, clean that up, 4a plus 2b plus c equals 16. And then what else do I know? Well, firstly, I'm hoping that you might start to see what's happening here and why I'm still looking for more information. I have 2 equations and 3 things missing. I need to keep going because the only way to solve this is to have 3 equations, 3 things missing. I'm looking for simultaneous equations. I need to solve what A, B, and C are. And in order to do that, I need a third equation. So hopefully as you were going along there, you might even recognize that and go, right, I think I know where this question is going.